today I am going to talk about CXPACKET wait type in SQL Server. The internet is flooded with a lot of information about this wait type, so I will focus on a few quick things about this wait type, and I'll keep it very short, very crisp, and very precise. So let's begin by understanding what exactly is this CXPACKET wait type, when does it occur, and if it occurs, if it is really a problem, and if you identify that it's a problem, then what can you really do about things. So CXPACKET stands for class exchange packet, and that means this wait type will occur when your workload, when your query is running in parallel. So of course SQL Server has this capability of running queries in parallel, which means more than one thread will be used by SQL Server database engine to execute your query. Technically speaking, the main thread, the controller thread, which with the thread ID of 0, will actually register for the CXPACKET wait type when it spins off multiple threads to execute the query, and then the CXPACKET counter keeps popping up. CXPACKET wait type will simply mean that there is parallelism happening in SQL Server, and it is a good thing. It's not a bad thing. You have multiple cores on your box and you want all those processors to be used, so it is essentially not a bad thing. But when CXPACKET wait types go very high, and when I say very high, what do I really mean? Well, I do not have any number to share with you, and it will be inappropriate to talk about any random number. But if you have a baseline, let's say you have a baseline of CXPACKET which is setting at 5 million, for example, and that's your typical trend, that you see a trend of CXPACKET at 5 million, and then you see for a particular period of time when you're collecting your performance data and when you're baselining, you see CXPACKET going very high, let's say 15 or 20 or 30 million. I'm just making up these numbers for you to understand that suddenly you see a spike and a lot of CXPACKET wait types are popping up, which means a lot of parallelism is going on. And then you may want to go and investigate if there is excessive parallelism happening inside SQL Server. And then you may want to go and troubleshoot all those queries and workloads to see if parallelism is really making sense for those workloads. So what SQL Server does is, by default, there is a property called cost threshold of parallelism, and the default value for that is 5. It's a server level setting, and the value is 5, which is a very low value. And 5 is just a cost here. There is no unit of measurement, it's just a number. And when you run your workload, you can always see the cost of your query from the execution plan. And if the cost of your query is more than 5, SQL Server will decide to choose a parallel plan for your query, and thereby there will be multiple threads that will execute the query. Now, because the value is so low, many queries with very low cost will also be parallelized, and that's not a good thing. And that is the thing really what you want to avoid, that queries with very low cost, they also use multiple threads to execute. And why it's not a good thing? Because in any SQL Server deployment, based on the number of processors that you have, there is something called as max worker thread, which is automatically computed for whether it's a 32-bit system or a 64-bit system. So think about a lot of small queries running in an OLTP heavy environment, and they come in, let's say, hundreds, and each of them are using 8, 16 or 32 threads. Then of course at a point might come where you will hit the max worker threads, and then there will not be enough threads in the system to accommodate the new requests. So you want to avoid such situations. So it is always advisable that you keep a check on CXPACKET, and there is good parallelism that is happening, and that should happen, but unwanted parallelism is something that you may want to get rid of. So how do you get rid of this so-called unwanted parallelism? Well, you cannot, or you should not set max dop to 1, which is a common advice that we see on the internet, because if you set max dop to 1 at the server level, you are essentially disabling parallelism. And you don't want to disable parallelism for all the good things, reasons that I just talked about. You want to use multiple resources, multiple CPUs that you have, and that's really the power of your hardware, and SQL Server can leverage that. So do not set max drop to 1. Instead, increase the threshold of this property CTP, cost threshold of parallelism. So set it to a higher value, something like 30, 35, 40, or maybe even 50 to begin with, and then you can fine tune it based on your analysis and review. When you increase this value to a more appropriate, a more reasonable number, you will see that many low-cost queries are now going to run in serial, which means they will use a single thread, and then CXPACKET wait type, and the overall wait time will come down. So this is one of the things that you can do. There are a couple of other things. For example, you can you can use max drop hint at the query level to fine tune every individual query, provided you have the permissions and you have that capability to do it. Sometimes ISV applications, you may not just be able to tamper with the query, so there might be a limitation there. So cost threshold of parallelism seems to be the safest bet in such a scenario. So let's go and look into a quick demo to understand what CXPACKET is, how does it occur. I will show you how a query is using multiple threads, and then we will set cost threshold of parallelism to a higher value, and then we will see that parallelism will not occur. And then I will also take a workload with parallelism and without parallelism and compare their performance, the execution plan performance, and also the runtime statistics to see how this overall things fit in the scheme of things. So let's begin with the demo, and let's understand more stuff from the workloads and the demos. For this demo, I'm using AdventureWorks 2008 R2 database, and the query is open in front of me. Let's first turn on set statistics time and statistics IO on. I click on execute. This will give us runtime statistics of our query and the workload. Use the database in this context, and let's go and look at what is the current wait time for CXPACKET. So if I do a select star on this DMV, DMOS wait stats, which has the wait stats information, and filter on CXPACKET wait type, I can see that currently there's a very small number there, and because I was just playing around with the queries right now, so that's the number, about 27,000 as wait time. And we can, for the purpose of demo, I will go ahead and clear the wait stats using dbcc SQL perf command. Please be aware that you shouldn't be doing this kind of stuff on your production bots. This is only for the purpose of demo. So when I clear off all the metrics and then I show you this CXPACKET wait time once again, you will see that all the numbers have been reset back to 0. Now we have this query, select star from sales order detail, and this table has over 1 lakh records, more than 100K, so a very small number. And I've done an order by on a particular column, line total descending. Now before I execute, I should turn on actual execution plan or just press Ctrl M, and let's go ahead and execute the query. This will go pretty fast. You get your output and look at the execution plan. And the moment you see the execution plan, it's pretty evident that there is parallelism happening. You can see all the parallel operators chosen by the database engine. And let's go one step further. And when I select the clustered index scan, because this is the operator that is responsible for scanning the data and fetching the rows off the disk, and I press F4 and to show the properties window, there is a field there which says actual number of rows, and you can see the number of rows is slightly over 100K. And when I expand this, this will give you the number of threads that were used to process this data. And as I mentioned earlier in the video, this is the controlling thread, thread 0, and there are 8 threads, thread 1 to thread 8, that actually do the job. And there is another thing that you will notice, that while some threads, like let's say thread 5 is processing 18,000 rows, there are other threads, let's say thread 6, which is only processing 12,000 rows. Well, this is how the algorithm is. The number of rows, the distribution is never going to be even. So when the execution starts, of course, there is going to be parallelism, and there is going to be CX packet wait, because thread 0 is going to register for CX packet, and then if these child threads, if any of them complete before the other and they're waiting, they will also register for CX packet. So you can see CX packet genuinely is not really a problem in SQL Server. It just simply means that there is parallelism happening. And what's the cost of this query? So if you take the cursor over select operator, you can see the cost of the query is about 4.3 units. Now remember, this is the cost of the query when the query is running in parallel. And if let's go back and let me first show you that now, because there was parallelism, you will see some numbers coming up for CX packet. Again, very low numbers. I was talking about millions, because yes, on production box, if you simply just run this query, and which is very safe to run on your production box because you're just reading some information, you will see pretty high values for this. Because if you have a big box with a lot of processors, you will see very high value there, and that's why I was talking about millions. And you can see some parallelism has happened, so there is some wait time and there are some task counts there. Now let's come back to the query cost. So you saw that the query cost, the query is gone. So the query cost was about 4 point something, and that was when the query is running in parallel. So yeah, this was the number 4.3. Now what if I run this query and force it to run in serial? I can use this query hint. Option max.1. Max.1 stands for maximum degree of parallelism, and it's a query hint, and I'm telling SQL Server and I'm telling the optimizer just use one thread. And when we execute this, now this is going to run in serial, and let's go and look into the execution plan. You will see that yeah, there are no parallel operators, and yes, and now actual number of rows is same, and you can see now just all threads means that this is a serial plan. And what is the cost of the query now? So the cost now is 10.4. So as I said, 10.4 is of course higher than 5, which is the default value for cost threshold of parallelism. So that should be changed. So if we look at, if we just really see what this value is, cost threshold of parallelism, before that because this is an advanced option, you need to turn this on. And now let's go and look at the value of cost threshold of parallelism, and this is going to be 5. So you can see the config value and the run value is 5, and as I said, this is a very low value, so let's go and change it to a more reasonable value, let's say 30 or something, and then let's reconfigure the system. So we put this back to we changed it to 30 now, and let's go back and run the query now, and we are going to run this without any hints. And now we will expect that this query is going to run on a single thread. So let's execute this again, and we go and look into the execution plan. Yes, it's a serial execution, no parallelism. You want to verify it further, but yeah, there are no parallel operators and it's just all threads. And what's the cost? Cost of course is 10.4, but now because the CTP thing is higher than 10.4, optimizer is not going to choose a parallel plan. Now most importantly, putting cost threshold of parallelism, assigning the right value, a more optimal value for that is the best solution to deal with this excessive or unwanted CX packet. And as I said, that baselining thing is very critical. When you are frequently recording CX packet numbers, let's say every 30 minutes or every 1 hour as part of your baseline, you will be able to see a trend. When you record this number, what I mean by is you're collecting wait stats, and then you're clearing off the wait stats DMV, and then you're collecting again. That's how you can build a trend over a period of time. And when you see abnormal trends like pretty high value, then you want to go and investigate. Let me go and set this value back to what it was, which is 5, and show you another dimension to this concept of parallelism. So I'll take this query, and in fact I'll take both of them and move it into a new query window and paste them here. And what I will try to do is run both of them together as a single batch to see the cost of the query in terms of the execution plan cost and of course in runtime statistics. So I will also have to take we'll take these two statements as well, because we also want to see the runtime stats. Only comparing execution plan performance may not be appropriate, so you also always want to see the runtime stats of the query. And now, just to be fair, this is what I'm trying to do. I will change this max drop from 1 to 4, and what I'm trying to understand is this by default optimizer is going to choose 8 threads, and here optimizer will choose 4 threads, and I want to see, is there a performance difference? And let's turn on actual execution plan and we click on execute, because the query, and this is what you really want to identify in your systems, all these workloads are really using parallelism, where even when they can really run pretty well with a single thread. So when I go and look into the execution plan, I can see that the cost is 50% and 50%. So the performance is really just very, let me take this number. Yeah, this is what I want to show you, 50% and 50%. So absolutely no difference when you're using 8 threads or 4 threads. So if I select this, how many threads were used? You can see there we are using 8 threads there. And what about the second execution? Because I used the max drop hint with a value of 4, I can see that now we are using 4 threads there, and performance is execution plan. From the optimizer's perspective, execution plan is all the same. But what about runtime statistics? So if we go into the messages tab and let's go and look at the runtime messages. So in the first case, we see the runtime stats here about 2044 milliseconds with CPU time 891. So this is interesting. This is the amount of time the query has spent on CPU, on the processors, and this is the total time it has taken from start to finish, including returning the results back to the client. So that is 891 and 2044. And when this is with 8 threads, and this is your number with 4 threads, 891. Wow, this is amazing. You just see the same number. That doesn't quite happen so often. So yeah, 891 with 2033 milliseconds. So there is absolutely negligible difference in terms of performance. And what I really wanted to do is to go one step further and really just change this to max drop 1. Let's make it absolutely a serial plan and see if we are almost at the same performance level. So let's go and execute both of them again. And let's wait for a few seconds for both queries to run, and yes, they are done. We go into the execution plan, and now you can see some performance difference. Now SQL Server Optimizer is telling you that the query with parallel plan with 8 threads is going to be less expensive compared to the one that we are running in serial fashion with 29% versus 71%. So there's quite a bit of difference, but I am going to go one step further and look at the runtime statistics, because sometimes just by looking at the execution plan in terms of comparing two workloads may not be the right thing to do. So when I go and look at the messages tab, let's go and look at the performance. What's the difference? Is it really considerable? Now, as it seems that because there were 8 threads, they spent more time on CPU because there were more resources being used there. So you have 936 milliseconds, and the time it took for the results to come in was about 2.3 seconds. And what happened when it ran serially? Well, the amount of resources were 578 seconds, and surprisingly, your elapsed time is even lesser than parallelism. So this is what I am trying to highlight, that look at this number, amount of time spent on CPU versus amount of time spent here when it was running in serial. So this is clearly a winner, and the number of seconds it took for the results to come back almost same in both cases. So there are always these kind of workloads that really do not benefit from parallelism. So yeah, go back in your environment, and first thing you need to see is cost threshold of parallelism. Is it set on the right thing? And that's one of the best practices that one should care about when you are setting up a new SQL Server deployment, to ensure that you set CTP to an optimal number to get rid of this excessive and unwanted parallelism. Hope the demo was useful and you have learned something new. Well, then thank you very much for your time for watching this video. I hope to meet you again soon in another video.